Okay, children, let me continue the same lesson. The previous class we have seen what is fluids. What are the fluids? What I said? There are three substances, gases and liquids are fluids because they can flow. They are acted on atmospheric pressure, that is thrust and pressure. We have seen what is the definition for thrust and what is the definition for pressure. Thrust is measured by Newton and pressure is Newton meter. How the pressure act in the fluids, that is liquids, we have seen. And what are the factors affecting the liquid? I said already, that is depth, density of liquid and acceleration due to gravity, we have seen. And atmospheric pressure, the air around us is known as atmosphere. The pressure exerted by the air is known as atmospheric air. It is found by the mercury barometer. The barometer was designed by Dirichlet. And next we have seen Pascal law. What is Pascal law? External pressure applied on an incompressible liquid. This Pascal's law, Archimedes Principle and all only for the liquids only. The Pascal law, pressure applied on an incompressible liquid, it is transmitted uniformly. So for example, what I said, based on the Pascal law, there is an appliance. The appliance is hydraulic press. Here how many pistons are there? 2 pistons. One is cross section is broader, other one is cross section is narrow. Whatever it may be, here the pressure is exerted equally in all the direction. We have seen that. And is known as multiple pressure, force multiplies. Now we have to say density. Density means that is comparison. Then how much, otherwise we can say the thing of correct time we have to say means, for example you see, here activity is given. You have taken round bottom flask. I showed the round bottom flask. You have to take round bottom flask. One you have filled with the kerosene, other one will fill with the mercury. Kerosene and other one water. Take 2 identical flasks because what? Why we are taking identical? There should be no. We have to say density now. Take 2 identical flasks and fill one flask with water and other flask with kerosene. Both are, we are taking, first we are finding out the identical flask. What you are taking for that? What are the 2 liquids you are taken? One is water, other one is kerosene. Both are you have taken in the same level, 250 only. The flask filled with water, then we are keeping on the balance. Balance means what? That is in Tamil we have to say tarasu. No, you are keeping on that. The flask filled with the water be heavier than with kerosene. So which is heavier? Water is heavier. Though both are in the same, water is heavier, this is lighter. Actually 250 only, though it seems to be 280 and then water is 330, kerosene is 280. From this we know 330 gram, this is 280 gram. We are taking identical flask 250 milliliters. Okay, why we are taking say equal level of water, equal level of kerosene only, but you are weighing which is heavier. Water is heavier than the kerosene because water has higher density than the kerosene. Water has higher density. The higher classes we are going means we can do by the practical also. That is test tube floating. We have to keep the test tube float with the mercury lead shots. You have to keep in the kerosene 3 times you have to keep and find out the reading. And we have to take water. This is, we are comparing. This is H1 and water is H2. The difference between H1 and H2 is known as density. We are taking the 2 liquids column. One is H1, other one is H2. Here, H1 is kerosene, H2 is water. The difference between these two is known as what? Density. The same thing when compared with one substance, for example, any substance, water as the constant, we are keeping water liquid, water is the main liquid. We have to compare with milk, kerosene, whatever the liquids you are giving, ether, alcohol, whatever it may be. So, we know the weight of water and we have to find out the weight of, we know the density of water and we have to find out the density of kerosene, alcohol, ether, whatever the liquid may be. So one is known, other one is unknown. The comparison between these two, that is keeping water as the main, it is known as what? Relative density. How we are saying relations, how they are relation to us? They are relation to any other way. Because, for example, if take myself, if my sister is there, she is my related. Because she is related to me. Enna base panni avangala solrom. Adupole water base panni we are finding out the density of other liquid. That is known as what? Relative density. Relative density we can find out by H1 by H2. So correct definition for density is, it's in page number 32, the first paragraph, last two lines. The density of a substance is the mass per unit volume of a given substance. So what is density? Mass per unit volume. Unit means particular. 1 unit, 2 unit, like that. Mass per unit volume is known as density. It is said by meters, that is centimeter cubed, or else we can say like this, the cube is the definition for density. Relative density I said already, mass of the substance given, mass of the water. So water, keeping water as constant, we have to find out the density of other liquids. That is known as what? Relative density. And relative density, there is no unit. Relative density, for density only we can say centimeter cube, and relative density there is no unit for that. We have to say the difference only, we cannot write centimeter cube or millimeter cube, whatever it may be. There is a density bottle. The density bottle is used piconometer. So relative density, now we have to say density. Relative density is used by a small bottle. The bottle name is, that is density bottle. The name itself what? Density bottle. Piconometer. This is otherwise known as density bottle. Clear? Then we have to say floating and sinking. You know what is floating, what is sinking? Sinking means the substance, the object, whatever it may be, either you can say substance or object, it entirely dissolved, immersed into the water. Thanikulla fulla moolgi irundha adena solveenga sinking. That is half of the body sink in the water, other half floating, that is submerged. That is known as what? Floating. Density of a substance is less than the density of the liquid, it will float. So two things you are taking, one is liquid, other one is solid. So you have to make the solid to immerse into the water. If the solid is lighter than water, it will float. If it is heavier than water, it will float. For example, balloon and stone. Both are solids only. Balloon is lighter than water, so it will float on that. But stone is heavier than water, so it has to sink in the water. This depends on density. Then based on the application of density, based on the flotation, we said no, flotation, floating. Based on that, we are making of instruments, floatation. Now, the flotation we have to say, what are the things of flotation? What are the floatation? I'll write here itself. You know what is floatation now? That is floating. Based on that, based on this principle, there are two instruments, appliances are there. One is hydrometer. Hydro, we know water. Other one is lactometer. Hydrometer to find out the density of liquids. Lactometer specially designed for to find out the density of liquid. Milk. For example, if the lactometer is used, we can find out in the milk how much of water is added. So we'll see the structure of hydrometer first. Hydrometers, it consists of cylindrical stem. See the diagram in 3.10. It consists of cylindrical stem having a spherical bulb at its lower end. Lower end, what is there? In bulb is there. And a narrow tube as its upper end. So test tube, this is inside the thing, it is there like this. This is hydrometer. The structure is given there, you see. This is cylindrical structure. The top it is open, closed. The down it is floated. This is only floating. This is only floating into the liquid. Here only we have to place the lid shards. Because of that it will float in the water. Readings will be there. Reading find out the readings. This is readings will be there in the measuring jar. This is measuring jar. Liquid is placed in this. Hydrometer is floated here. Measurement will be there. We have to find out. The same hydrometer you have to take out. With some other, first we have to keep in the water. Other thing for which we have to find out the density. Suppose kerosene, ether, alcohol, whatever it gives. First you have to keep in the water. You have to find out the density of water. Then you have to compare with the liquid what is given. You have to place the same hydrometer with the same lid shards without changing. Wipe in water and again keep in the other test tube. What is placed? Either kerosene, alcohol, whatever it may be placed, you have to see. The difference between this is water is H1, the given liquid is known as H2. The differentiation between H and H2 is known as relative density. Clear? So the hydrometers may be used for different uses such as lactometer for measuring the density of creaminess of milk. Then saccharometer for measuring the density of sugar in the liquid, and alcohol meter for measuring the higher levels of alcohol in spirits. So there are three kinds of hydrometers. What are the three kinds of hydrometer? Let me write here. What are the hydrometers? First one is lactometer. I said just now. To find out the liquid, that is milk. How much of liquid is added in this. Second one is saccharometer. Saccharide nalle sugar. To find out the sugar level in the liquids. And the last one is alcohol meter. The levels of alcohol. Then next lactometer, it works on the principle of gravity of milk. Gravity of milk, that is density of milk. How much milk is there, how much water is added, easily we can find out by using lactometer. So lactometer measurements 15 at the bottom, 45 at last. Lactometers are used for the milk processing units in the dairies. Dairies means what? That is milk producing industries. Now we have to say hydrometer, you know well. Now we have to go for, then what I said? Density, relative density. What are the instruments based on that I said? Hydrometers, what are the hydrometers? Lactometer, saccharometer, alcohol meter, lactometer to find out the purity of milk, saccharometer to find out sugar level, and alcohol meter for how much of alcohol present in the solution. Now you have to go for buoyancy. So we have saying relative pressure, that is pressure compared with H1 and H2, that is water column as well as liquid column. The pressure differences cause force of an object and pushes it upward, because if it is heavier object, float, sink. If it is lighter objects, it forces. So this force, it is pushed out, the force is called buoyant force. That is force which exerted on the object and makes the object to push out. It is known as what? Buoyant force, and the process is known as buoyancy. The exerted pressure, exerted force is known as what? Buoyant. So let me rub the board. The force exerted is known as buoyant force, and the process is known as buoyancy. Then by using the buoyancy, we can make a driver that is Cartesian driver, that is nothing else. It's a pen cap with the clay. Pen cap is filled with the clay. Now Archimedes principle, the principle is found out by Archimedes. So what is Archimedes principle? Only few things, let me complete the class. Archimedes principle, to honor the scientist, I said already, it is named by Archimedes. A body immersed in a fluid experiences vertical upward buoyant force equal to the weight of the fluid displaces. That means a body immersed in a fluid experiences vertical upward buoyant force equal to the weight of the fluid displaces. What is it? If a body is immersed in the water, for example, if you are immersed, if you are immersing a stone into the water, then the weight of the stone, no, for example, it is 50 gram, the equal amount of the water, equal amount of the stones will be, equal amount of the stone weight will be displaced. That is, if you are taking a water and you are immersing the stone in that, then equal amount of stone's weight of water will be displaced. This is known as what? Archimedes principle. So that is given in page number 34 at the last second paragraph, left side. A body immersed in a fluid means what? Liquid, experiences a vertical upward buoyant force equal to the weight of the liquid displaces. For example, you can see, cylinder you have taken water, you are immersing, that after immersing, that is spring balance, the weight will be decreased. So water, equal amount of water will be displaced. So laws of flotation, we have to see. Let me complete the lesson. Laws of flotation. What is law of flotation we have seen now. Then what are the laws of flotation? The weight of the floating body in a fluid is equal to the weight of the liquid displaced by the body. I said already, the stone weight, if you are placing the stone in the water displaces. The water, displaced water and the stone weight both will be same. Next one, the center of gravity of the floating body and the center of buoyancy are in the same vertical line. They are acted on the same line. That is, the body is immersed out and they are leaving out the water, no. That water, the center of gravity of the floating body and the center of buoyancy both lying in the same vertical line, same line only. Clear? Archimedes principle you want to see the diagram. The first one you have taken, that is overflowing jar. The jar what you have taken is overflowing, that is figure 3.13. You are taking overflowing jar. The overflowing jar, the spring balance you have taken, you have to find out you have to tie the stone and note down the reading. Then you have to immerse the stone into the water which is displaced. First we are finding the weight of the stone, no, that is W1. Then you are immersing the stone into the water. That is W2. W1 is more than W2. Because the weight of the stone, the same amount of water will be displaced. Displaced water and the losing weight, both you are same, means both will be same. So the lesson we have come across, what are the things we have come across? We have seen what is thrust and what is pressure, how the pressure act on the fluids. Fluid means I say liquids and gases, and what are the factors determining the pressure of the liquid. And we have just seen what is atmospheric pressure, how to find out the atmospheric pressure. And then Pascal law, based on the Pascal law, hydraulic press is made. And density we are finding out, that's for the liquid only. Relative density, which is keeping two liquids you are taken, one is water, other one is unknown, whatever given to you. And laws of flotation we have seen. The two laws I said, buoyancy. The entire process is buoyancy. Exerted force is known as what? Buoyant force.